So I'm here with Rob to talk about telehandler safety. We've already covered in Earth Movers magazine the importance of tyre management on telehandlers, both getting the pressures right, the actual load ratings of the tyres and matching tyres across axles. But what we want to talk about this afternoon is the stability triangle. What is the stability triangle?
Good question. Something a lot of people don't understand. Basically, you've got a solid front axle that doesn't pivot during normal operation. The rear axle is pivoting. It pivots side to side to allow you to travel on rough terrain with all four wheels on the ground. So basically, you've got a solid axle, so you end up with a line from the centre of this axle to the centre of the rear axle, and again from the centre of this wheel here over to the centre of the axle, making a triangle like this. Anywhere inside that triangle is the stability triangle of the machine. So anywhere within there, if the centre of gravity is within that, then the machine stays upright. When you get close to the edge of that or outside of that, then you're in a very high risk area of the machine perhaps toppling over.
And what improves the stability triangle or increases it, and what diminishes the triangle?
Obviously on this machine we've got stabilisers on the front of the model and the machine in the yard. You can make the chassis longer, you can make it wider, or you could add counterweights at the back. If you make it too wide or too long, you miss out on manoeuvrability. So it either won't turn within the site conditions, or it's too long to fit in. The counterweight is a slightly different one because in some parts, some elements of the movement of the boom, the counterweight, if there's too much on the back of the machine, can have a negative effect on it.
So what are the common faults that cause tip-over accidents with telehandlers?
I would say a lot of it's down to operator. I mean, what the operator does, the machine will follow the operator's instructions. It's not a crane. It does what the operator says. It has some devices which try to reduce the risk of him doing unsafe things, but a lot of it does come down to the operator.
And these devices, what do they actually stop, or what do they prevent?
Okay, well, the latest innovation, which is a European legislative title, is EN 15000. Or we call it a movement cutout device because it's much easier to understand, stops the machine as the boom comes out, and the back end effectively becomes lighter because it's a seesaw. As that becomes lighter, it stops any movements of the boom which would cause the machine to topple over forward and the rear end of the machine to come out.
And how does it know it's about to topple over, or how does it know it's the centre of gravity is getting outside of the stability triangle?
It's got a sensor on the back of the back axle, a strain gauge, which gives an indication to an electronic device, which turns that into a visible and an audible signal. It gives an electronic signal, and then that's keyed into the hydraulics to actually cut them out when it becomes a condition where it's becoming likely to topple over.
But we're only talking about toppling over forwards.
Exactly,
Yes.
exactly. That device is looking forward. In terms of sideways stability, that is down to the operator. It's up to the operator, first of all, to get the machine absolutely vertical. It's also down to that operator to have a load placed in the right position. And working with suspended loads is different as well. He doesn't want something that's going to be swinging around there.
So even though brand new machines all comply with European legislation, it's still down to the operator. It's still down to the operator to understand the basic physics involved.
The operator is a critical point. Yes, he has to be well trained, skilled. The machine has to be in good condition, and he has to be working within the constraints of that machine. He has to be using the devices on the machine. I mean, he can see the boom angle from an electronic readout in the cab. He's got a chart which tells him how much he can lift at different readouts, different distances away. So at full extension, he's reduced his capacity. When he's in here, he can lift more capacity. He has that information, but he has to make decisions based on that information.
And what happens if the operator feels he's getting into a point of being unstable? What can he actually do?
Okay, well, if the machine cuts out, so if it gets forward so it's light to do a forward topple, then he can do anything that brings the weight backwards, from further within the stability triangle. So if he retracts the boom, quite simply, he could bring it in. The machine locks out any tilt function because that could have an action making the weight go forward. So he can retract the boom, which brings it back, or he can raise it.
Raise it?
Yeah, this is one that people often get confused on. They think because lowering it brings your centre of gravity down. They think that's a logical thing to do. But in actual fact, if you imagine the weight here, as you raise it, it's actually moving backwards, so it's moving.
Right. And if you lower the boom without retracting it, the weight goes forward.
Exactly. If you're there and you lower it to here, you're moving the weight forward. Yeah, it's one that's difficult to get your head around immediately. It's a conceptual thing, but once you've got it, it's important.
Now, I've seen some pictures. We may even have published some in the picture post section of Earth Movers of telehandlers toppling over without a load on.
Okay, well that may be the worst condition. That's a good point. If you take this back, no load on it at all, you bring it back here, you've got all the weight of this boom structure that we talked about, lots of heavy components within it, acting, moving the centre of gravity back. In actual fact, putting the load on it here might actually bring the centre of gravity further forward.
So having a load on is actually safer.
Exactly. Probably that condition there is the most risky area, and people don't always realise that.
So if you had one big message to say to telehandler operators to improve site safety, what would that be?
One message. It's work within the constraints of all the advice that the manufacturer's put into his operator's handbook. It's, the machine needs to be well maintained, and the operator needs to be highly skilled, trained and capable of looking after that, working with that machine. He might get his ticket, but he might not have experience. Experience is very valuable, isn't it?
Absolutely, there's nothing to beat it.
Yeah.
And talking about experience, I think we've had enough in the office. Shall we get outside?
Let's go and have a look, yeah.
Excellent. We've talked about the theory. Now we're outside in the demonstration ground to talk about the practice. The important thing to remember is any fancy electronic system on the machine is no substitute for good operator skills and experience. So Rob, why don't we just add some weights to the back of this? That'll make it more stable, won't it?
That's a great question, Graham. If we look, when the machine weight went forward, that seems like the obvious answer. It all goes forward, put more weight on the back, we can lift more at the top, more at the front of the machine. But the next thing we have to do is go up in the air, and then it all becomes a little bit more complicated.
More complicated because it's in 3D?
That's exactly it, yeah. We're working in a 2D plane here, really. We're working forwards and backwards. It's just like a seesaw. Put more weight on one end, more weight on the other end, it balances out. When you get up in the air, it actually becomes a pyramid. So you're talking about a stability triangle we started with. That goes to a point in the air. When you're up in the air, obviously it's a much finer tolerance left to right. Any small angle movement in the machine obviously moves the weight across quite considerably, and then things become pretty dangerous if you don't do it correctly.
I guess other areas of the industries sorted these problems, like the crane boys have very sophisticated control systems, but I guess we must remember this isn't a crane, it's a telehandler, and the LMI system is just for 2 dimensions.
That's it, really. I mean, to have a crane technology on it would be great, but we'd double the price of the telehandler.
And double the price of the operator.
Yeah, exactly. Higher skill level, different type of skill level. Yeah. The steps forward we've taken with the cutout devices will be a great improvement in the industry for safety, because they'll take away some of the risks, but as you say, it doesn't compensate for the chances of an unskilled operator taking control of a machine.
And from what I know, it certainly will minimise, if not cut out completely, all the forward tipping accidents. But what about side tipping accidents?
Side tipping is a complex subject. I think what we noticed on the theory was, in actual fact, the place where people don't realise is when you're fully back with the weight right back over the machine, that's when you're at your highest risk. You're closest to the edge of your triangle, and that's not obviously instinctive when people talk about it. So that's the kind of education, knowledge, training that I think needs to be progressed.